All right, here we go. We've got lesson 4 coming right at you here. We're going to add on to our inequalities stuff. With this lesson, we're going to do compound inequalities. So there basically is 2 inequalities in the same problem. We've got some using the word and if they use the word and, that just means in order to be a true solution to the inequality, it has to work for both of them. So it has to be where the 2 inequalities overlap. We call that an intersection. So if we look at these 2 separate inequalities, x is greater than or equal to 3, x is less than 7, where do they overlap? Right here becomes your solution set. You can write it, if it's an and, you can write it like that as 1 inequality. Well, whatever, I guess it's 2 inequalities, but you're sharing 1 variable. So when they give you problems, sorry, I already did this once, but it decided not to record me. So you'll see what I did here on example 1. They actually set it up as 1 inequality, but with the 2 separate signs. It's essentially 2 problems. So if you want to rewrite that, which is what I did, -3 is less than or equal to 3x plus 6, and 3x plus 6 is less than 12, then I solved each of them separately using the rules we always use. Okay, so I subtracted 6 from both sides, and then I divided by 3. On this side, I get -3 is less than x, which typically I would say, yes, we want to write like this. X is greater than -3. But because we're going to write it as 1 inequality where they share the variable, you can write it like that. They give you 3 over here, not that you need to graph them separately in order to find your intersection. I truly believe you guys can probably go straight here, and that's fine, but that's where it comes from. This one goes this way, this one goes that way, and then so the solution is where they overlap. On the bottom of the page, you're going to find 2 more examples. I've already finished them because, as I said, the first time I recorded this, it didn't work quite well. So if you want to pause me right now and take a second and work on those and see if you get the same answers, now would be a good time to do that. But you'll see on the first example, they were 2 separate problems, but we could write it like this. Which means it's between those 2. Notice I squiggled the line in there, and over here I have them separately, and either way, you could do this either way. It's completely up to you. Okay, when you're ready, on the back side, they're going to do word problems. Okay, a company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall it could be. So it needs to be at least, so 11.2, bigger than or equal to is the height, and then less than or equal to 11.4. Now this is kind of goofy because we got decimals in there. So if I'm doing this, I'm going to start at 11 and 12 and just do. So here's 1, 2, 3, 4, 11.5, right? And so I've got from here to here, and we are shading between there. And there you have it. Okay, now the other type of compound inequality is the ones using an or. Okay, so just like we know what the definition, or we know how we use or, it can be, if it's a solution, it doesn't have to work for both of them, for one or the other. And this works when we have things going in opposite directions. You'll see in this example, if it's greater than 2 or less than -1, it's never going to overlap. That's why they have to use the or. If this were an and, there would be no solution because there's no shared answers. But because it's an or, it's a union of 2 different inequalities, and so it's either one. All right, so let's do this example problem number 2 at the bottom of this back page. It says movie tickets for a child younger than 13 cost $5.95. A movie ticket for an adult, 13 to 64 costs $8.95. A ticket for a senior citizen, 65 or older, is also $5.95. All right. Write and graph an inequality that describes the ages of the people whose tickets cost $5.95. Well, $5.95, the ages have to be either younger than 13 or older, or 65 and older. Okay, so the inequality, we could have an age that would be younger than 13, or if our age is 65 or bigger, that also works. So there's our two separate ones. If I were to graph that, younger than 13, greater than or equal to 65. So here is my compound inequality. And there you have it. Now that one I can't write together because my inequalities don't really work on that one. So when there's an or, you just have to write them as two separate answers. All right, last page. Example number 3. Solve and graph a union. In other words, an or problem. So you see you got the two inequalities. Let's solve each one separately using our order of operations. We get a is greater than 7. On the right one, I'm going to subtract 11. And now notice when I divide here, I'm dividing both sides by negative. So we must switch our signs. We learned that yesterday. So 2. So my first one, a has to be greater than 7. And a has to be less than or equal to 2. So my union, which includes both of them, looks like so. Okay, one last problem, which is kind of funny because they flat out gave you that first one. We have to solve the second one. So minus 2, I get 4x is less than 8, divide by 4, and x is less than 2. But they also told us that x could be less than or equal to 9. Okay, if I were to graph these two, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that first one looks like this. The second one looks like this. And so if it's a union, if it's an or, if it works for one or the other, then the only one I need to use is this one, because that first one right here would include all of those answers as well. Everything less than 9 is going to be include the ones less than 2. All right. So at this point, you can get your worksheet and have at it. We will talk more about this tomorrow. Have a good one.